Hello, once again, Mr. Wakefield here, looking at section 10.2, and this is now the third of the four different methods that we're going to look at for solving quadratic equations. Completing the square is what it's called. And once again, like I said, with the square root property, when we take the next exam, you will have at least one question where you must use the completing the square method to solve the equation given. And of course, you need to also use that method here. That's why it says it here in the directions. So it is important, obviously, then that you need to learn the method. Okay, even though sometimes, in fact, all the time, really, these problems where it says complete the square in the directions, you could theoretically not use all of the other different methods. You don't have a choice of any of those necessarily. They won't all work. They won't all work. But some of them, some of the other ones would. But in order to make sure that you've learned the method, I need to make sure that you do use completing the square both in the worksheet here and also in your homework. It'll say in the directions in your homework for 10.2 to complete the square. And then, like I said, at least one test question will also say that you must complete the square on that particular problem. So make sure that you learn the method and let me know if you have any questions. Okay, so let's get into it here. What we're doing here, unlike, say, for example, the factoring method that we learned in section 7.5 at the end of the last packet, instead of moving all the terms to one side, we are going to move the x squared term and the x term to one side of the equal sign, but then the term that doesn't have the variable in it, okay, c represents just some constant number here, that term would then be put on the other side. But there's something else here that's extremely important, and students oftentimes lose a lot of points if they don't do this because it's near the beginning of the problem and it just messes up the whole problem if you don't do it right. Make sure, and we kind of talked about something similar to this in the last section, make sure that this right here is x squared. It can't be 5x squared. It can't be 4t squared. You need to change it so that it's x squared, and you need to change this one over here so that it's t squared. Okay? You can't have a number in front of it. All right? You can't even have a negative sign in front of it. It just has to be x squared and t squared. All right? So how do we do that? And by the way, notice that we already have the x squared term and the x term on one side of the equal sign, and the term that doesn't have the variable in it on the other side, just like they want us to. Okay. If that's not the case, as is such here, notice that this is the term that doesn't have the variable in it. That thing you'll have to move over here. Okay, and we'll do that on the next problem. But here it's already set up for us where the terms are in the right place. But as it says here, you also need this to not have a number in front of it. So how are we going to get rid of that 5 right there? The way we do it is we divide both sides of the entire equation. You can't just divide the 5x squared only. If you want to divide part of an equation by something, you got to divide the entire left side of the equal sign and the entire right side of the equal sign by that same thing. All right, so that's why I put a fraction mark all the way across the left side of the equal sign and then across the right side of the equal sign here as well. Okay, and this is going to kind of look like a problem or some problems we did back in 4.4, all right, where I had to get, in this case, get the y by itself and do that y equal to mx plus b thing that we did, where you're doing on one side of the equal sign, you've got two terms. On the other side, you got just one. So on the side that you just have one, you just divide it, okay, and you put it in lowest terms, okay, because you just got a term divided by a term. You just put it in lowest terms. You don't have to factor or anything. 10 divided by 5. If you want to cancel, it ends up being 2 over 1, or since it divides evenly here, 10 divided by 5. Either way, you're going to end up with 2. Right? Okay, whether it's 2 over 1 when you cancel or if you just straight divide, it's going to end up being equal to 2 either way. Okay, but on the other side, just like we did in 4.4, if you've got two terms divided by one term, what you do is you divide each one of them individually here. Okay, negative 4x divided by 3, I got that right here. And 18 divided by 3, I did that over here. Make sure your signs in front of each fraction are correct. Okay, and then you put each fraction in lowest terms, and we did that. We're going to do that exact same thing here. Okay, I'm going to go positive divided by positive is positive, so I have positive in front, and you don't need to put the plus if it's the first fraction. Okay, if it was negative, you'd put the negative there. Okay, and then you then put that in lowest terms on the next step. Then you have positive 30x divided by positive 5. That's equal to positive, so I put a plus in front of the second fraction, just like we were doing before when we had two terms divided by a term. And then what you do, like I said, is you put both fractions in lowest terms. Okay? Remember, don't cross cancel here. You can't cross cancel when you're adding, only when you're multiplying. But stay within the same fraction here, this fraction and this fraction. Keep the fractions separate and put them both separately in lowest terms. So the 5 and the 5 cancel. And then the 30 and the 5 cancel. 6 and 1 there. And so we end up with what here? We end up with 1x squared over 1, which is the same thing as just x squared. Because when you divide by 1, you don't need to write that normally, right? Bring down the plus. And then we got what? 6x over 1, which is the same thing as 6x, right? And so we get that. Doesn't it now look like this, you guys? You've got x squared with nothing in front of it. You've got the x term. And it's okay if this is minus sometimes. In this problem, it's plus. But if it was minus, that would also be okay. But then we've got the x to the first term here. And then on the other side of the equal sign, we've got the term that doesn't have the variable in it, the constant term, in other words. So it now looks like this. It is extremely important that you do not move on to step 2 down here unless it looks like this first. Okay? But now that it does, it says right here in step 2 to apply the completing the square technique. The completing the square technique is at the very top of the page. It says to take the side that has the variables on it and add to that this thing right here. What is this thing? Well, first of all, before we know what this thing is, we got to know what that B letter is right there. The B letter is the coefficient of the x term. Okay, see how that would be 6 right here? See how the coefficient of the x term, x to the first term, is going to be 6? And so we take that. And what does it say to do with that B number? It says to take 6 divided by 2, because B is 6. 6 divided by 2, and put it in a bracket and then square it. So 6 divided by 2, and then square that outside the bracket. I'm just writing this right here. Okay? But do it off to the side here so we can figure it out. Okay, what you do in order to figure this out is we know that parentheses come before exponents when you do order of operations, which we're going to do right here because there's no variables here, and we need to figure out what this is equal to. 6 divided by 2 is 3. We then square that and we get 9. Okay, so it says to add this thing, which ends up being equal to 9, to both sides of the equation. Okay? Actually, it doesn't say that here, but I'm telling you. It says to add that. And what they really mean by that is to add it to both sides of the equation. Let me show you that. Okay, so we're going to take the same equation here. And we are going to add 9 to both sides. The real motivation here is to add the 9 to the side that has the variables on it. You'll see why here in a second. But you can't... In fact, I'm going to use... actually, this is okay. But I need to, since I add 9 to one side, I need to add 9 to the other side as well. You can never add something to one side of an equation without adding it to the other. Okay, the same amount. All right, but we need to add it to this side for a very special reason, very particular reason that I'll show you in the next step. But like I said, you can't do something to one side without doing it to the other side. And that's why I had to put the plus 9 over here, so don't forget that. Okay, so whatever this thing is equal to here, you got to add it to both sides. Okay, now here's what we do. What happens here is this looks like something you can factor, doesn't it? From the factoring chapter. It looks like a Berry method problem. Well, if you did this problem correctly, you should be able to factor it unless it has fractions in it. And I'll show you a shortcut in case you do end up with fractions here. But if there's no fractions, the Berry method should work just fine. What you do is you go, and you might be wondering, wait a second, we're not supposed to factor this unless there's a 0 over here, right? Didn't we learn that in section 7.5? Yes, we did, but since this is a completely different method here, we are allowed to factor this even though this is not 0. It's a different method. When you're doing the 7.5 method, yes, you need to have a 0 over here before you can factor on this side where the variables are, okay? But this is different. So we're going to factor this, and you'll see why it's good to factor it here in just a moment. Let me factor it first, and then I'll explain that. Okay, so we do 1 times 9 is 9. And we know that the Berry method says that we need to find two numbers that add up to 6 that equal 9 when we multiply them. Wouldn't that be 3 and 3? And so since this is 1x squared, this would be 1x and 1x. And since these are both positive 3, we're going to have plus 3 and plus 3. Okay. When you do this step right here, if these two brackets are not the same, you did something wrong. They should always be the same exact two brackets, x plus 3 and x plus 3. Okay. But they are, so we're fine. Okay. That's why we call it complete. Well, I'll explain that actually in the next step. But the fact that these two brackets are the same means that, in fact, let me go ahead and finish this off over here first, and then I'll explain that. 2 plus 9 is 11, right? Now, on the next step, since these two brackets are the same when we're multiplying them, that means that it's the same thing as this right here. 11 is still there. Okay, so if these two brackets are the same, and they should be, you then rewrite it as the bracket being squared. Because when you multiply two things that are the same thing, it's the same thing as squaring them, right? Taking them to the second power. Okay, this is the reason why they call it completing the square. Because in the last section, the square root property section, we learned that if you have a bracket being squared all by itself on one side of the equal sign, and then you have a term that doesn't have a variable in it on the other side, you can do the square root property with the double square root here. Okay, so that's what we need to do to finish off this problem. Okay, the two brackets have to be the same. If they are, you go like this. You write down the square. Okay, only one bracket with the square now. All right, so the two brackets become one bracket with the exponent 2. It then looks like a problem from the previous section, 10.1, and then we use that square root property from that section to finish this problem off. Okay, so let's do that. So we're going to write down x plus 3 equal to square root of 11. X plus 3 equal to negative square root of 11. Exactly the same thing we did in the last section. That's why I'm doing this. Okay, that's why I wrote down what I wrote down. Then we learned in the last section that we need to get x by itself if it's not already. Okay. Remember, the radical, because it doesn't have a variable in it, is no different than just a normal constant term there. And so I need to move, as we learned in the last section, we need to move the 3 over to get the x by itself by either adding or subtracting it over. In this case, we subtract because it's positive 3. Okay. What do we get here? We get x is equal to negative 3 plus square root of 11, and we get x is equal to negative 3 minus square root of 11. Okay, writing it down exactly the same way we learned how to write it down in the last section. Once we get the x by itself, when we do the square root property, what did we learn? We learned that there's two things we got to check. Number one is the radical simplified. Yes, it is, but we need to check that. It is simplified, though. And then the last thing that we do is we do that thing where we condense the problem down in, if you're able to. Okay, if the two answers look the same except for you have a plus in one spot and then in the other answer you got a negative in that same exact spot, then you do that thing where you condense down the answer. But only if that's true, though. Only if they look the same except for you have a plus in one spot and then a minus in the same spot in the other answer. Since that's the case, I'm going to condense down the answer like this, and now we're finally done. Okay, so 3 major steps to the completing the square technique. You first of all got to get it in this form where the x terms are on one side in this order and the term without the variable is on the other side. You then do this thing right here, add it to both sides so that when you then factor this part, you then get the same 2 brackets so that you can then write it like this with the exponent too. Okay, that's the second step. You can break that up into 2 steps actually, but I call it all 1 step right there. And then the last step is to do the method from the last section to finish the problem off and get x by itself. Let's try that again now in problem B. Okay, now remember, they want the term that doesn't have the variable in it. They want that on the other side. So before you get rid of that 4 right here, like we said that you have to do, okay, we need to move over that 7. So get the term that doesn't have the variable in on the other side first before you get rid of the coefficient of the square term here. All right, and the way to do that, assuming there's no parentheses to clear out first, the way we move a term, the entire term, not just part of the term, but the entire term here, over to the other side is to add or subtract it over. In this case, I'm going to subtract it over because it's positive 7. If that had said minus 7 at the top right there, then we'd say plus 7 to move it over, right? And so we get this right here, don't we? Okay. Then what do we do? Now it looks kind of like this problem here at the beginning, right? Where you got the square term here, just like you got the t squared term here, and then you got the variable to the first power here, x to the first and t to the first. And then you've got the constant term on the other side, no variable there. So then we do that same thing, only now we're going to divide by not 5 this time, but we're going to divide by 4. You divide by the coefficient of the square term here, in this case t squared, whereas over here we divided by the x squared term. Okay, the coefficient of the x squared term. So we divide both sides by that, bring a fraction bar all the way across so that you can divide all the terms. We then do that thing where and you can't divide this and you can't put this in lowest terms. It already is in lowest terms. So just leave this the way it is, negative 7/4. Okay, don't make it into a decimal. Just keep it as a fraction. That's fine. But then you take both of these and you divide them individually here. Positive divided by positive is positive. So don't put a minus in front of that. Okay, that should be an invisible positive in front of that. But then we have negative divided by positive is negative, so we're going to put a minus in front of that. And then we put both of those fractions in lowest terms on the left-hand side of the equal sign. What do these become here when I put these in lowest terms? Again, keep them separate. Don't cross-cancel here because it's only when you're multiplying, not when you're subtracting fractions, like we are here. So keep the fractions separate, put them both in the lowest terms, and what do we get? We get 1t squared over 1, same thing as t squared. Bring down the minus, and then when we cancel here, we get 4t over 1, same thing as 4t. And there you go. All right. Now what do we do? Once we get into this form right here where you got t squared and t on one side of the equal sign, the term without the variable in it on the other side, that's when you do the thing here with the bracket and the b over 2 inside of it. Okay, so that's going to, in this case, what is the coefficient of the t to the first term? Remember over here we did 6 because that was the coefficient of the x to the first term. In the same way, what's the coefficient of t to the first? It's negative 4. Don't do 4, do negative 4. Okay? Figure out what the inside is equal to first, then square it. The inside, negative 4 divided by 2 is negative 2. We square it and we get 4. Okay? Because you're squaring, you should always get a positive answer here. Okay? So that thing that you add to both sides, you know, like in the last problem where we added 9 to both sides, that thing that you add to both sides, in this case it's 4, that thing should always be positive. So I'm going to add 4 to the left-hand side, and also I'm going to add 4 to the right-hand side as well. Okay. We got some work to do here in order to figure out what this is equal to because of the fraction, but we'll get to that. Okay. We know how to add fractions. We'll figure that out. But what is this equal to? Remember I said that after you add that number to both sides, you got to factor this, right? Okay. And we did the Berry method on that. We'll do that same thing here in this problem. So the Berry method says 1 times 4 is 4. And then what two numbers add up to negative 4 that also equal positive 4 when you multiply them? That would be negative 2 and negative 2. Okay. And so since this is 1t squared, you're going to get 1t and 1t. And then negative 2, you just put those in there. And once again, you can see that I got the same two brackets. They have to be the same, okay? Otherwise, you won't be able to do this thing where you say bracket squared. They have to be the same, all right, because that needs to happen. That's just part of the complete and the square technique. That should happen. It needs to happen. Okay, now, what's the other side equal to, though? How do I add a fraction to just a normal number? We've learned that in the past. That's where you take the number that's just a normal number and put it over 1, and then you add the two fractions together. But adding fractions means that we need a LCD, right? Whenever one of your denominators is equal to something and the other one is just equal to 1, okay, that means that the LCD is equal to the other number 4, okay? So if you've got 4 and 1, the LCD would be 4, all right? So what do I got to do to make it the same? I got to multiply this one by 4, right? The other one's just going to stay the same, isn't it? Sorry, I messed up there. That should be 16. 4 times 4 is 16. And then, and remember to keep this negative on the inside of the numerator there. Don't let it drift outside the fraction. We've talked about that before as well. When you're adding or subtracting fractions, all right, don't allow there to be a negative in front of the first fraction, because then it'll get forgotten about, okay? It's real easy to forget about it. But it has to be a part of the process here, so make sure it stays in the numerator if it's not in there already. So negative 7 plus 16 is 9. The denominator stays the same, as always, in that case. And so this is equal to 9/4. So now what do we do? Just like we did over here, when the two brackets are the same, we can then say bracket squared like this. The other side is still 9/4. And then we do on the next step here, we do the completing the square. Okay. So that's going to be what? It's going to be t minus 2 square, I'm sorry. The square goes away when you do that, right? When you do the double square root, the square goes away. Excuse me there. So we get what? We get t minus 2 is equal to the square root of 9/4. Or t minus 2 is equal to negative square root of 9/4. Okay. Now, as I told you guys before, if you have a number or fraction that's a perfect square, okay, I'll show you that in fact here. Just a reminder of when we talked about that in the last section. Remember I said that when you do the double square root and you get a perfect square, such as 25, or if you get a fraction where both the top and bottom are perfect squares, go ahead and figure out what the radical is equal to first, so that when you move the 2 over, it's easier, okay? The radical won't be, you'll be able to combine it because the radical won't be there anymore. You'll be able to combine the 2 with whatever's left over here. So what is that radical equal to? Isn't that equal to 3/2? So we have 3/2 and we have negative 3/2. Then you move over the 2 to get the t by itself, right? We got some more adding of fractions to do here, don't we? Okay. What is 3 halves plus 2, and what is negative 3 halves plus 2? All right. 3 halves plus 2 would be 3 halves plus 2 over 1. Okay. And that would be what? That would be, again, when one of your denominators is equal to 1, and there's only one other denominator, that the LCD, I apologize, the LCD is not 4. That was from the last part. The LCD is equal to the other denominator. So if it's 2 and 1, the LCD is 2. So we're going to get the first denominator stays the same. The second one we multiply by 2. And so we get 3 halves plus 4 halves right here. What is 3 halves plus 4 halves? That is 7 halves. So t is equal to 7 halves. The 2's cancel on the other side. What happens, though, if it's negative 3 halves plus 2? Well, it's exactly the same answer. I won't rewrite this again because it's almost identical. It's just that you're going to have a negative in front there. But as I just mentioned a moment ago, when the first fraction has a minus in front and you're adding or subtracting, you want to move that into the what? Into the numerator here so that it doesn't get forgotten. Okay, so then that means what? That means that this is going to become what? It's going to become negative 3 plus 4 over 2, which then would be 1 over 2, right? So the first one is 7 over 2. The second one's going to be 1 over 2. Notice that we got t by itself, but there are no radicals to simplify. So you don't need to do that step. We normally do that when we do the square root property after you get the variable by itself. But then also you can't do that plus or minus thing here because these two things don't look the same. These two answers don't look the same like they do on a lot of the other square root property situations. So just circle that. Okay. And that's it, all right? We got t by itself. We didn't have to do those other two things I just mentioned with the simplifying of the radicals or the plus-minus thing, so we're done. Okay. One more here, and I'll let you guys try some here. You can see the problem C looks very similar to problem A, okay? The variable squared and the variable, those two terms are on one side. The term that doesn't have the variable in it is on the other side. So we can jump right into that step where we divide out to get rid of the 8 in front of the w squared. Remember, the square term cannot have anything in front of it, right? Okay, so I need to divide by that coefficient of that squared term in order to get w squared only with nothing in front of it. So just do the same thing we did in the last two problems here. Okay, we are going to take these two terms, split them into two separate fractions, like this. They're both positive divided by positive, so we have positive in front of each answer, there in front of each fraction. On the other side of the equal sign, 32 divided by 8, whether you put it in lowest terms or you just divide it, because this does divide evenly, either way it's going to be equal to either 4 over 1 or it's going to be equal to 4. Either way you can say 4. Then you put the two fractions in lowest terms like we've done in the last couple of problems. The 8's cancel on both of those. And we get w squared over 1 and w over 1. Same thing as what I wrote down just now, w squared plus w. Okay? Now this problem might look kind of simple to you, okay? The numbers aren't too big, it doesn't look too bad, okay? But it's going to get a little bit weird here right now, but don't worry, we'll get through it. You just got to be patient, okay? There are going to be some fractions that are going to appear here. We're going to have to do things slightly differently, so listen closely, you'll be fine, okay? But notice that it is now in that form that we need it to be in, okay? Where you got the square term with nothing in front of it. You've got w to the first right here, okay? And the coefficient is going to be 1 because you don't see a coefficient there and it's plus, so it's going to be positive 1. And then the 4 right here. So it's in the correct form that it needs to be in order to go on to the next step. But the b number is positive 1. So that means that we're going to do 1 over 2 squared. Remember, the b number goes on top and above the 2 right there. Okay, what's different this time is that this doesn't divide evenly. On the previous two problems, okay, we had 6 divided by 2, it divided evenly. We just got 3, and then here it divided evenly was equal to -2. If it doesn't divide evenly, 1 divided by 2, then just put the fraction in lowest terms if it's not already. It already is. 1 over 2 is already in lowest terms. And then after you've done that, just go ahead and square it as it is. So square the entire fraction. And as we've learned in the past, when you square a fraction, it means to square the top and square the bottom and create a brand new fraction. In other words, we do 1 squared over 2 squared like this. We did that at the beginning of the semester when we were doing exponent rules in sections 2.1 through 2.3. Okay, and we end up with what here? We end up with 1/4. Like I said, we're going to end up with some fractions here, okay? What do we do, though, when we figure out what this thing is equal to on the previous two problems? What did we do? We took that answer and we added it to both sides, right? Like that. And then after adding it to both sides, what we did was we factored that thing. And then we also figured out what that was equal to. We'll get to that in a minute. But there's a problem here. We don't normally factor when you got a fraction like that here. Okay. Normally we factor something like this where there's no fractions in it, right? Okay. And the truth is that you don't need to factor this. There is a shortcut to it. And in fact, you could actually use the shortcut that I'm about to show you. You can use it on this here as well. Even though we didn't do that, you could, okay? So I'm showing you could do it when there's no fraction here on the left-hand side. When you get to the step, you could do it either way. You could do the factoring or you could do the shortcut. All right, so I wanted to show you both things, the factoring and then the shortcut I'm going to show you now. But when you do have a fraction, when you get to this step, after you add the same amount to both sides here, okay, if you end up with a fraction on the side that has the variables on it, please do the shortcut that I'm about ready to show you so you don't have to worry about the factoring step, okay, which again, we didn't learn about factoring when you got a fraction inside of the polynomial here like this. Here's the shortcut. We're going to jump right to that step where we have the square on the outside, okay, which is what it always ends up being anyway, right? You always end up with the bracket square. So part of the shortcut is being able to jump all the way to that step. But I want to show you something here, and this will help you understand what the shortcut is, and then we'll come back to the problem. In the previous two problems, notice that the number that went next to the variable inside of the bracket, it's not a coincidence that this is +3 right here and right next to x, isn't it? And what was the thing that I squared up here? Not the b number, but after you divided by 2, what was the thing that you squared? It was 3, right? So +3, +3. Again, I'm not talking about the b number. I'm not talking about the final answer after you square it. I'm talking about the thing here in the middle, the thing that you squared. +3, +3. That is not a coincidence. Let me show you over here. The same thing happened over here. What did we end up with inside of that bracket that was being squared? Next to the variable, we had -2, right? Not a coincidence that what's up here in the middle here, after you divided by 2, but before you got the answer, what's being squared here? -2. Same thing. So my point is that, and this works 100% of the time, the thing that you square when you do that b over 2 squared thing, the thing that you end up squaring here in the middle, that is the thing that goes into the bracket with the variable. Just remember that you've got to have either a plus or minus in between. If it's negative, you put a minus, okay, in the middle here, and if it's positive, you got to put the plus. All right, so you put the variable first, just x, not 2x or 3x, but just x, and then you put the number that's being squared here with a plus or minus in front of it, depending on the sign. Okay, so what was the thing that I squared here? All right, the thing that I squared here, since the 1/2 didn't, we couldn't put that in lower terms or whatever, that thing that we squared was 1/2 itself. Okay, I know this right here is in the middle right here, but that I just wrote it a little bit differently here. The point is that the thing that you squared to get 1/4 as the answer, that was 1/2, positive 1/2. And so because it's positive 1/2, what you do is you bring down the variable, just w, not 2w or 3w, but just w, just like up here I just brought down x, okay, just w. And then since it's positive 1/2 that you squared, we're going to say what? We're going to say plus 1/2. Okay? So that's how it works. All right? So if this had been negative 1/3 inside of here, okay, that you squared instead of positive 1/2, then you would have had minus 1/3 right here instead of plus 1/2. Okay? Now, how do I do 4 plus 1/4? Again, if you have a regular number being added to a fraction, you put a 1 underneath that regular number right there, 4/1. You do your LCD since you're adding the fractions, and we get, let me just go ahead and do it here. We get 4 times 4 gives me 16/4. The 1/4 stays the same because it's we just want the denominator to be equal to 4. And so we end up with 16 plus 1 is 17. So 17/4. Lots of fractions now, right? Okay, so fractions just means we need to be a little bit more patient. We know how to deal with fractions, don't we? It's just that they're not as fun to deal with as regular numbers, are they? Okay, I agree with that idea. I agree with that. But we'll be fine. We'll get through this here. So the next step, now that we have a bracket squared by itself and a term without a variable in on the other side, that means that we do the square root property from the last section. Okay? Like this. Put the negative in front of that other, that second radical there like we always do. And then, I know that with all these fractions it looks kind of weird compared to normal. But remember, the 1/2 doesn't have a variable in it, and the radical doesn't either. So this is no different than if you had something, I'm just pretending here, but it's no different than if you have something like this, w plus 3 equal to 5. The 3 and the 5, because they are terms with no variables in it, okay, they're no different than 1/2 and the radical 17/4, okay? And so what you do is you just move the 3 over with the 5 if it was this problem. But since we're doing these problems instead, just like moving over the 3, wouldn't we move over the 1/2? Like this. Okay, and the 1/2 would cancel. And we get w by itself equal to negative 1/2 plus the square root of 17/4. Okay, just like we wrote in the last section, you've got a positive minus a 1/2 is the same thing as going negative 1/2 plus the radical. Okay, plus in front of that radical because it's positive in front of this radical here. And then here, they both have a minus in front of it, so when I reverse it around, it's going to be negative 1/2 minus 17/4. They still have a minus in front of both of them. Okay. Now, once we get w by itself after doing the square root property, we try to simplify the radical. All right. Unless both of these numbers are perfect squares, you don't need to simplify. I don't ever ask you to simplify a fraction. We did rationalize the denominator with a fraction inside of a radical, but we didn't simplify the radical. So you can leave it like that unless both of these numbers are perfect squares, but only the 4 is, not the 17. So you can leave it like that. And then the other thing is we do that plus or minus thing, which we can do in this case because the two answers look the same except for in the middle, right? A plus in the middle here, a minus in the middle here. So the final answer is this right here. The textbook, if you're checking your answers in the back of the book, which is always a good idea, they write down this answer a little bit differently. I'll show you how they do that on a similar problem when you guys try your 3 problems here. I'll show you how they do that at the end. It's at the end of the third problem. Okay, but this is perfectly acceptable. You tried to simplify the radical, but you couldn't because it was a fraction, and there was the two numbers weren't both perfect squares like we saw earlier with the 9/4. Okay, the 9/4 here, we simplified that because they were both perfect squares, 9 and 4. 17 is not, so you can leave it like that. I will show you how the textbook does it, though, so that you can compare your answers to the back of the book if you're concerned about that. And again, that's always a good idea. But try the three problems that I have for you here first. Number 1 on the first page, number 2 and number 3 on the second. And like I said, I'll show you how to write the answer the textbook way at the end of doing the third problem here. But go and try it first and get the answer initially here the same way we did here, and then we'll talk about that. So do 1, 2, and 3, and then hit the play button. Okay, number 1, remember when the term without the variable in it is on the same side as the variable terms, you first of all need to move that over. Okay, since that's minus 14, we need to add it over to the other side. That gives us this right here. Okay, but remember, you got to get rid of that 2. So very important. Okay, a lot of students forget to get rid of this 2 before they do this this thing over here where you add the B number and all that. It completely ruins the problem, you guys, in so many ways. And therefore, it costs students a lot of points. So very, very important we remember to do this step. We need to divide by 2 since it's 2y squared. We do that normal thing that I've been telling you about where you split it up here, the 2 terms on the left. You split them up. You put them both in lowest terms. The 2 and the 2 cancel right here. The 8 and the 2 reduce down to 4 over 1. And that's why you get y squared plus 4y. And then 14 over 2 equals 7. So y squared plus 4y equal to 7. Now that it's in the correct form that we need, before we go on into the B step right there where you do the B number, okay, now I can take the coefficient of the y to the first term, which is the B number, and that would be positive 4 here. We bring that up here. We divide by 2. That gives me 2. And then we square it. That gives me 4. So because it's equal to 4, we add 4 to both sides of the equation. That gives me 11 over here. And I'm going to go ahead and just do the shortcut right now. Okay, you could factor this and it'll give you the same thing, just like we did on the first 2 problems on the first page. Okay, you could factor this because there's no fractions in it. It'll give you the same answer, promise you. Okay, you'll get y plus 2 times y plus 2, which then becomes this. But the shortcut once again is what? What is the number that we squared up here when we did the b over 2 step here? It's 2. Okay, the number we squared to get the answer was 2. And so since it's positive 2 up here that we squared, we say plus 2 inside of the bracket. All right. And so that's why we got y plus 2 squared equal to 11, whether you factor it or you do the shortcut. Now that it's in the square root property format that we learned in 10.1, we then now do the double square root thing. Okay, but we also need to move over the 2 to the other side after that in order to get y by itself. I did all of that, as you can see here. After we get y by itself, we check to see if the radicals are already simplified. They are. 11 cannot be simplified. But these 2 answers do look exactly the same except for the plus and the minus in the middle of the answers, right? And so because of that, I can then condense the final answer down to negative 2 plus or minus the square root of 11. And so that would be then your final answer. Okay? Number 1. Let's go to the second page here and look at problems 2 and 3. Number 2. Again, we already, interesting here, it's already in the form that we need it to be in. Remember, it needs to be x squared with nothing in front of it, and then you need the x term, and then you need the term without the variable in it. It's already in that form, okay? Remember, it's okay to be minus in front of the x term, that's fine. And so we don't need to do the first step at all. It's already done for us. We now then can do that B step, where we take the coefficient of x, which is negative 2 right here. We divide it by 2 and then square it. When we divide by 2, it's negative 1. Then we square the negative 1, we get positive 1. So that means that I need to add 1, this right here, we add 1 to both sides. Okay? Doing the shortcut, we realized that the thing I squared up here was negative 1, so we're going to get x minus 1 inside of that bracket there, just before we do the square root property. Okay, don't forget the exponent. 8 plus 1 is equal to 9, so bring the 9 down. Then we do the square root property with the two square roots. Okay, and that gives me what here? That gives me a couple of square roots that are perfect squares underneath the radicals. Okay, just like we had with the square root of 25 earlier. Remember, and also the square root of 9/4. Figure out what that radical is equal to if it's a perfect square underneath it. So I figured it out. It's 3 and negative 3, right? 3 and negative 3, because the square root of 9 is 3. That makes it easier to move the 1 over. That's why I figure out what the radical is equal to first, okay, if it's a perfect square underneath. All right. Then you add the 1 over to the other side, and our final answers are 4 and negative 2. No radicals to simplify, no plus or minus, because these two answers don't look the same in any kind of way. Just leave it like that. Number 2. And finally, number 3. Okay. We need to move the 18 over to the other side. Okay, as you guys now know, the x squared term and the x term need to be on one side. The term that doesn't have the variable in it needs to be on the other. So I move that over. I then need to get rid of the 6 in front of the x squared. I do that by dividing by the 6, like that. I then get this right here because I need to do what? I need to do, I kind of went a little bit faster because we've done a lot of these examples now. But just in case, I'll show it to you. Okay, 6x squared divided by 6, the 6's cancel. 6x divided by 6, the 6 is canceled. That's why we end up with x squared plus x. 18 divided by 6 is 3. Okay. And so now we have, in the correct form here that I talked about, it's now in this form right here. And so we can then move on into that B step there. And the coefficient of x is positive 1 here, isn't it? It's 1 because it's invisible, and it's positive because of the plus. So B is positive 1. And we saw this earlier, didn't we? Okay. 1 divided by 2 is 1/2. You can't do anything with that. And you can't do 1 divided by 2. You can't put that in lowest terms. It's just 1/2. So we square the 1/2. We get 1/4. Again, similar to earlier. So we add 1/4 to both sides. All right. But because it was 1/2 that we squared, you guys, that means that the bracket, the big bracket down here, is going to have positive 1/2 next to the variable. Positive 1/2. So you got to put the plus there when it's positive in that case. We then figure out that 3 plus 1/4 over here to the side, getting a common denominator, we get 12/4 plus 1/4 is 13/4. So this is the 3 plus 1/4 drops down here as 13/4. Okay. Then, again, you can see it's looking very similar to problem C on the first page. We then do the double square root thing. You got this right here. All right. But I still need to move the 1/2 over to the other side, just like I did in problem C on the front. Okay, and that gets x by itself. Like I said, you don't have to simplify a radical that has a fraction in it. Okay, unless both of the numbers are perfect square numbers. The 13 is not, though, so you don't have to do that. So then we do the plus or minus thing here, though, because the answers look the same except for the middle here, plus and minus. Okay, so this is okay. That's why I said this is okay. This is okay if you have a question like this on the test or homework, okay, and you write your answer like this, that's okay. But if you want to check to make sure the answer is correct by comparing it with the book, okay, The way to do that, as I promised you that I'd show you, is like this. You rationalize the denominator when you have a fraction inside your radical in one of these completing the square problems. Okay, you rationalize the denominator. The way we did that back in 9.5 is we first of all split the 13 and the 4. Okay, back in 9.5 we learned how to do that. If you've got a fraction inside the radical, it splits that. Then you simplify the bottom before you try to get rid of the radical on the bottom. However, in this case, and this is what's nice about this, when you simplify the radical on the bottom, it just becomes 2, okay, because it's a perfect square underneath the radical. So you don't need to do that step. Remember those problems where, just to remind you in case you're not remembering 9.5. Remember, suppose it had been 13 over 3 instead of 13 over 4. Remember we had to do this thing where you had to multiply both of them by square root of 3? You don't need to do that here because if you simplify the radical 4 first, like we normally do, and the radical 3 wouldn't simplify here. That's why I jumped right to the multiplication step here. But the radical 4 does simplify. It's just equal to 2 because it's a perfect square. The radical goes away. You just figure out what the radical is equal to. And since there's no radical anymore, you don't have to do that thing when you multiply. The whole purpose of that multiplying step in that section was if there was still a radical there. Well, there's not here in the actual problem that we're doing right now. And so we rationalized the denominator, meaning that we got rid of the radical in the denominator. That was the whole purpose from 9.5 is to get rid of the radical in the denominator and just get a normal term down there. Well, 2 is a normal term, so we're good. The other thing that they did when the textbook gives the answer in the back of the book is that since these two denominators are the same, they add the numerators together. Add or subtract, okay? This means addition and subtraction here. So we can do that because the denominators are the same. Now, you can't combine these together because they're not like terms, -1 and radical 13. But when you are adding or subtracting numerators together, when the denominator is the same, if they're not like terms, you can still say that they're being added together or subtracted, okay? You just can't combine them. So that's why I kept the plus and minus in between it. Okay, to say that it's still separate, it was not combined into one term. Okay, also remember, like I said, when you're adding and subtracting fractions, if you have a minus in front of the first fraction, bring it into the numerator, and that's why you end up with -1 plus or minus radical 13. Okay, so the plus minus means that you're both adding and subtracting. You're doing both of those things, and that's why the plus and minus ends up here. So in a similar way, you guys, just for practice here, you don't have to do this, but let's look at it side by side here. Here's the problem that we did on the front side of the worksheet. That one right there. Okay, how would I make it look like something like this, which is what the back of the book does? Again, you would rationalize the denominator on that, just like I did with the rad 13 over 4 right here. Okay, I'm going to split it apart. Again, this is completely optional, just if you're looking at the back of the book and you want to see if it's the same answer. Then we simplify the bottom, and it's equal to 2, so you don't have to do that multiplication thing here that I was talking. You don't have to do that. So what do we have here now? We now have W is equal to -1/2 plus or minus rad 17 over 2. Okay? Because the radical with the fraction inside of it becomes this fraction right here. Since the denominators are now the same, I now can what? First of all, I need to put this negative inside of the numerator, since it's a negative in front of the first fraction there. And then since the denominators are the same, I can say what here? I can say -1 plus or minus the square root of 17. Do not combine those, though, because a radical term is never like terms with a regular term like -1 that doesn't have a radical in it. All right, so that's what the book would say the answer is. Okay, so this is the book. Completely optional, like I said. This right here is perfectly okay to do. You can leave your answer like that. All right? So there's a way that the book does it sometimes. Sometimes it's different than what we do here on the lecture video. Okay. So I wanted to clear that up. All right. So that's completing the square, you guys. Let me know if you have any questions about it. Okay, we will in the next video look at the fourth and final method that we still need to look at for solving quadratic equations. Okay, but again, yeah, let me know if you have any questions, because again, you need to know how to complete the square. You need to know how to do the square root property as well. And of course, you still need to know how to do the factoring method from 7.5. I'll get into that more here as we go through the worksheet packet. That method will come back, and it will be something that we're going to want to know still. Okay, we don't want to forget it. All right, so you're going to want to remember that as well. But we're also, of course, going to want to know the fourth method after we learn it in 10.3 in the next video. Okay, so we'll see you back here for the 10.3 video. You take care and have a good day.